If you are taking thermodynamics class, you can't miss properties tables. They are thermodynamics properties for different substances. Many properties are measurable and can be calculated based on the relations of its measurements. They are conveniently presented in the form of tables. They are usually listed in more than one table for each substance. First, I would like to show you the TV diagram. As you can see, we have three kinds of phase: compressed liquid, saturated mixtures of liquid vapor, and superheated vapor. These are the three titles you will see for your tables. They are applicable for all pure substances. For example, we can have a table of saturated water and another one for saturated refrigerant 134A. But in this video, I will use water as the main substance to explain the properties tables. Why these tables exist? The answer is very simple. To give you more data about all the intensive properties of a pure substance. In addition to temperature, pressure, specific volume, you will also find information about the substance internal energy, enthalpy and entropy. All these data are very helpful when you need to calculate the energy of mass streams flowing in and out of control volumes. You also need them to solve first law and second law of thermodynamics problems. Let's start with saturated water. Usually, you will find two tables for the saturated water. One with the saturated temperature and one with the saturated pressure, because the temperature and the pressure are dependent properties during a phase change. Both tables give the same information. You will observe a decreasing latent heat of vaporization as the temperature or the pressure increases. When it reaches the critical point, the enthalpy of vaporization will equal to 0. In other words, you need more energy to vaporize 1 unit of saturated liquid water at 100 degrees than at 150. As there's a mixture of liquid vapor in the saturated region, we can determine the moisture of the substance, also called quality vapor. It's an intensive and independent property. It is equal to the mass of saturated vapor over the total mass, which means the percent of vapor mass. Now, you can observe that the table for compressed liquid water begins at 5 megapascals. It's 50 times higher than the atmospheric pressure. Below 5 megapascals, we can treat compressed liquid water as saturated liquid water because the error involved is less than 1%. Therefore, we can approximate Y equals YF at the same temperature. Remember that Y can be replaced by V, U, H. You can recognize a compressed liquid when the given temperature is lower than saturation temperature, so it is for V, U, and H. Finally, we will talk about superheated vapor. It comes right after saturated vapor line if you keep heating till the temperatures are above the critical point. Unlike saturated vapor, superheated vapor has absorbed extra heat and won't be easily to condense. Since superheated region is a one-phase region with only vapor, the temperature and pressure are no longer dependent properties. They will be illustrated as two independent properties in the tables. The superheated vapor is distinguished by its lower pressures and higher temperatures, specific volumes, internal energies and enthalpies.